There are many, many interesting groups in the periodic table. It is a wonder of excitement. Group 2 is not part of that wonder of excitement, unfortunately. However, we're going to do it nonetheless. So, Group 2, it starts with beryllium, probably one of the more exciting ones, which we're not allowed to use. And then we hit magnesium, calcium, strontium, and barium. Now, they are incredibly useful, and we wouldn't be here without them. But just chemistry-wise, not hugely exciting what we do. So, Group 2, we start off with beryllium, and then we're going to go magnesium, calcium, strontium, and barium. Now, often they'll ask you to do the electronic configuration of these. So you know, when you're doing these, you could use in square brackets the noble gas, the previous noble gas. So for beryllium, if I look at my periodic table, the noble gas with a lower atomic number is helium. Now, beryllium is in period 2 of my periodic table. So the big number for beryllium is going to be 2, because he's period 2. What group is he, which subshell is he going to be filling up for beryllium? Brilliant, he's in the S block. And if he's in group 2, how many electrons are going to be in that? 2. Fantastic. So, it's easy peasy. So, magnesium, my noble gas is going to be neon. And all I do is I change the 2, because magnesium's in period 3, but he's still going to be S2. They're all the same. Calcium is going to be argon, so he's 4S2. Strontium is going to be krypton, so he's 5S2. And finally, barium is going to be xenon, which is 6S2. So it's really easy to do these electron configurations. What people get confused about is they will say, oh, okay, so you can use this notation, I want barium. And they go, oh, I've never got to barium before, I've never done all of that, how am I going to do that? Easy. It's in period 6, so it's 6. You know it's going to be the S block, S, and he's group 2, so it's 2. And that's how you do it, easy peasy. So they all have 2 electrons in their outermost shell. They're always going to have this S2 configuration. So, let's have a look at a couple of trends. Now, this is going to recap periodicity, so we should be all right here. So, let's have a think about atomic radii, or atomic radii. What's going to happen as I go down the group to my atomic radii? Down the group, atomic radii will they increase or decrease? So, down the group, are they going to get bigger or smaller? They're going to increase, yeah, they've got to increase because they're having more shells, aren't they? Atomic radii will increase down the group. And that's obviously, they're going to have more shells. More shells are being added. And the outer electrons are more shielded from the nucleus. So they've got to get bigger. So that's the first. Atomic radii are going to increase because of that. What's the other thing we have to look at? Well, we have to look at ionisation energies. So, based on the fact that my atomic radii are going to increase, what's going to happen to my ionisation energies? Ionisation energies will 50-50 chance here. What do we reckon?
They will decrease because it's easier to use the electrons.
Fabulous. Decrease down the group. So the things that we always include, they will decrease down the group because although the nuclear charge increases. The outer electrons are further away from the nucleus, and more shielded. Therefore, less attracted to the nucleus. So those are my things that I always have to include. We can just clarify it. Less attracted to nucleus and easier to remove. Just to make sure. Keep the examiner happy. So you're happy, we always have to include, we include the trend, nuclear charge, shielding, atomic radius. What's going to happen to the attraction? Is it easy to remove? That's a really dodgy one. Okay, so this is all recapping periodicity. So nothing surprising there.